Welcome back, Warhawks. This is Mr. Tipton with another edition of Carnegie Math here at Seminole High School. Today we're going to do Chapter 5.3, which is Triangle Inequalities. It can be a little tricky, but if you watch the video, I think it should be a good explanation of how to do these questions. So the first thing we get to is the angles of a triangle. What we see here is the smallest angle of a triangle is across from the smallest side. The largest angle is going to be across from the longest side. So in this triangle, I look and see my three side lengths, 6, 11, and 14. I want to be able to list these angles from the smallest to the largest. So I need to find my shortest side. 6 is my shortest side. And you can even kind of see here from the picture that C appears to be the smallest angle. And it is going to be the smallest angle because C is across from the side that's marked 6. So C will be my smallest angle. The next smallest angle will be across from the side that's 11. 11 is my medium length side, so the angle that's across from that would be B. It's the angle that doesn't touch the side. And then my largest angle is going to be across from my longest side. Here you can see angle A is across from the side that's 14. And a lot of times they'll appear, or you can kind of tell by looking at them which one's going to be longest, but you always want to go by the measurements. So A is across from my longest side, 14. So the lengths of these triangles from shortest to longest, or the angles would be C is the shortest, B is the medium, and A is the largest angle, listed from shortest to longest. So that first part there should have been pretty simple. Now we get to the harder stuff. Any two sides of a triangle must add up to be larger than the third. So we're given a triangle picture here. We have side lengths 5, 7, and 8. Now what this is essentially saying is that any of these two sides that I add together, there's three sides, so I have three possible combinations, must add up to be larger than the third. So I'm going to start with 5 and 7. Is 5 plus 7 greater than 8? Which is what we must have here. 5 plus 7 is 12. 12 is greater than 8. That works. Now I'm going to look at 5 and 8. Is 5 plus 8 greater than 7? Yes, 5 plus 8 is 13. 13 is greater than 7. So far, so good. And then I want to check the last one. Is 7 plus 8 greater than 5? And the answer, of course, is yes. 7 plus 8 is 15. That's greater than 5. So all three of these must be true for it to be able to form a triangle. Let me show you an example of why this is so. If I look at this next example here, I have three side lengths. Now this isn't a triangle yet, but I have a side length 4, a side length 8, and a side length 16. Now, based on that, we know that we have to add any two of these sides to be greater than the third. So I'm just going to start with the obvious one. Is 4 plus 8 greater than 16? And the answer is no, it is not greater than 16. Let me show you why this doesn't work. If I took this side that was 4, I put it down here at the end, and I tried to make a triangle out of it, and I take this side that's 8 and I put it at the other end and try to use that to make a triangle, I'm never going to be able to connect those because 4 and 8 don't end up being larger than 16. They're just not long enough to connect it. Okay, so that's why this doesn't work. Even if I laid these flat against there, they're still never going to reach each other. So that's why any two sides must add up to be larger than the third. So here we have a situation where if you're given two sides of a triangle, we can do this to find the third. Now, I'm not saying what the measurement of the third is going to be. I'm saying what it possibly could be. So let's look at 6 and 9. 6 plus 9 has to be greater than the third side, which I'm going to end up calling, we'll just call it X. So when we add 6 plus 9, we get 15. That means that this side must be less than 15. It can be anything less than 15, but it can't be 15, it can't be 16, can't be 17. So it has to be less than 15. But let's think about it. Could a side like a length of 2 work right here? If I put something like 2 there, well, we think about it, is 2 plus 9 greater than 6? Yes. But is 2 plus 6 greater than 9? And the answer is no. So it can't be any number that's less than 15. How are we going to find that third one? Well, let's think about it here. So I look at these two numbers. What numbers could I add to 6 that are greater than 9? Well, I could add 4, I could add 5, I could add 6, I could add 7. All those work. What numbers could I add to 9 to be greater than 6? Well, really, I could add any number to 9, and it's still going to be greater than 6. But there's a couple numbers that don't work, like the number 1. 1 plus 6 is 7. That's not greater than 9. Number 2 doesn't work. 2 plus 6 is 8. That's not greater than 9. And even 3 doesn't work. 3 plus 6 is 9, and 9 is not greater than 9. So how do I get this magical cutoff? Well, here's what I do. I'm going to take, and I'm going to say this. I know that when I add 6 plus x, it has to be greater than 9. Well, look at this as an equation. How could I get x by itself? Well, I would just subtract 6 from both sides, and I get x must be greater than 3. So there's my two parameters. X could technically be any side that was between 3 and 15. It could be 4, it could be 5, 6, 7, 8, 9, 10, 11, 12, 13, or 14. But it can't be 3 or less. It can't be 15 or more. And I know that looking from the picture we see, well, it couldn't possibly be 4 because that looks like the longest side. I'm not, again, saying what the length is. I'm just saying what it could possibly be. Okay, I hope you enjoyed this video. I hope it was informative, and we'll see you in class.